These notes are on inverse relations. So a relation where, oh, sorry, that's the definition. I apologize. So this is the definition of an inverse relation, is a relation where the x and y values of the original relation are switched. If f of x in the original relation is a function, if f of x is the notation. If f of x is the original relation, then f to the negative 1 of x is the inverse function. And we say this as f of x, f inverse of x. And then just to note that not all functions have an inverse that is a function. So we're going to do an example here that has many different pieces. The first piece is we're going to determine if the original relation given is a function. So you'll remember that for a relation to be a function, each input has to have a unique output. In this case, 1, -7, 0, -3 all have one answer that comes out. So this is a function. I then need to find the inverse. And the inverse, again, is where the x's and the y's get switched. So 2, 1, 4, -7, 9, 0, and 6, -3. And 2, 4, 9, 6 all have only one output, so it is also a function. Second example, g of x. So we'll look first if it's a function. So I have 2, -4, 6, -11. Each of those have only one output. If I say -4, you say 8. If I say 6, you say 8. It doesn't matter that you said 8 twice in a row just now because I started with a different x and you gave me only one answer. So this is a function. G inverse of x. Switch the x's and y's. 3, 2, 8, -4, 8, 6, 4, -11. Now in this case, I have two 8s. So if I were to say to you 3, you would say the output is 2. But if I say to you the input is 8, you're going to have to say to me, well, it's either -4 or 6. And the minute you have to say two of them, you have to say that either, that means it is not a function. Last example of this type where you're given points. So I have h of x, I have 2, -4, 2, 3. I repeated the 2's. In this case, when I give you an x of 2, you're going to say your output is 4 or -7. So that's not a function. Give me two more than one answer, not a function. H inverse of x, 4, 2, 8, -4, -7, 2, and -10, 3. In this case, if I say 4, 8, -7, -10, you give me one answer for each of them, so this one is a function. A second topic that you looked at when you were talking about these inverse functions is graphing them. So first, again, I'm going to determine if the original relation is a function, and this is. So f of x is a function. And the important point here for looking at it, if it's a function on a graph, is to see when you line your pencil up vertically, how many values do you hit? So for 1x, how many values, y values? Just one, so it is a function. Then for graphing the inverse of f of x, I'm going to take, in this case it's a line, so I'm going to take 2 points. This point right here is 0, -2. If I switch the x and the y, I get -2, 0. And then I'm going to pick this point right here. That one is 6, 0. If I switch those, I'm going to get 0, 6. And I connect these 2 points and label that f inverse of x. Now, for those of you who are seeing some nice patterns here, you'll notice that there's a line of symmetry here for f of x and f inverse of x. And just a little sort of preview for Math 3, that line of symmetry is y equals x. So y equals x is the line of symmetry. Example 2. In example 2, we have a exponential function. It is a function. So we say, an f inverse of x is also a function. They both pass the vertical line test, meaning when I put my pen down and I'm looking vertically for for f of x, I only hit the function one time, and for f inverse of x, the same thing. So g of x is a function. Now I'm going to graph g inverse. So let's see here. Maybe I will pick this point right here, which is 3, 8. So switch the x's and the y's. That's going to be 8, 3. Let's see. Let's pick this point right here, which is 0, 1. And then I'm going to want over here that to be 1, 0. And then I know that the general shape here is, and I can see here that it's an exponential, so it comes close to hitting that x-axis, but it never does. So when I flip it, it kind of flattens out there, and it continues to go up there. And so this is the g inverse of x. Now, exponential functions, when we're looking at the inverse, it may look a little like it's not a function, but it actually is. And that's because these points here, they never actually make a straight line. They're always getting closer and closer and closer to the y-axis without ever touching it. So it turns out that g inverse of x is also a function. The last thing you were asked to do dealing with inverse functions was to actually find the inverse given a function. So we're given f of x equals 7x plus 3, and we're asked to find the inverse function. And this is really important. It's going to come into play in these examples. So remember that in order to find the inverse, I'm switching the x's and the y's. So the first thing I'm going to do is I'm going to just rewrite this using y's. I then am going to switch the x's and the y's. The y becomes an x, and the x becomes a y. That is an inverse. Right there, it's done. Except that's not how we write it. Remember, the notation we've been using has that f-1 power business. So I need to actually have it look like that, which means I need to solve for y. So I subtract 3 on both sides. I divide by 7 on both sides. And then I write it in my very fancy fashion as f inverse of x equals x minus 3 over 7. And this was a line originally. This is a line again. It's a function. I'm all good. G of x. So again, I'm going to rewrite this as y equals x minus 3 squared minus 8. Make my y an x. Make my x a y. Solve for y. X plus 8 equals y minus 3 squared. However, when I take the square root of both sides, I have a positive and a negative, because I got an absolute value happening. So I have the square root of x plus 8, but a positive and a negative piece, y minus 3. I add 3 to both sides. Now, if I were to graph this, and actually let me take out my graphing calculator really quickly and show you what this looks like. So remember that the original function is x minus 3 minus 8. And it looks like, oh, I'm going to get a slightly different window here. Let's go to Zoom Standard and see if that gives me a good picture. And no, it doesn't. I think I may have made a mistake in my equation. Yes, I did. I was graphing a line there for a second. So I'm going to insert a squared. put it in the wrong place. Just start again, make it nice and easy. Squared minus 8. Okay, now I graph, and I'll get a parabola this time instead of a line, and there's a great parabola. Now we know that an inverse function is going to reflect this along the line y equals x. So we just did all that lovely work, so let's actually plug that in. So I have 3 plus the square root of x plus 8, and I have 3 minus the square root of x plus 8. I graph that. And look at that lovely shape. I have my original parabola, which for my calculator, because it comes in color, is in blue. And then I have the inverse of that parabola in red and black. So turns out, though, that that inverse parabola isn't a function. And the directions said here that I needed to write it as a function. So mathematicians decided at some point that there was just a convention here, that in order to have the inverse of a parabola still be a function, they were going to use the positive branch only. So the positive branch only, g inverse of x, is going to be 3 plus the square root of x plus 8.